So thank you, everybody. Thank you so much for coming along and supporting us. I know it's been a long year of virtual events, and we're probably all getting a bit of virtual event fatigue, but thank you so much for supporting tonight's event and supporting us throughout the year. Gregor and myself are the kind of organisers and the people behind this user group. We are both here in the chat tonight, and you can reach us out on Twitter if there's any questions, complaints even, suggestions for things to do next year. Please do reach out to us as well. Just a note around our code of conduct. I know we're all a friendly group and stuff, but just continue on being that friendly and welcoming group of people that I know you all are. I know some of us know each other, but please be welcoming to the people in the chat joining us tonight who aren't regulars or don't know anybody. And please be respectful to each other and also to our speakers as well. Just makes it all go much more smoothly for all of us and can be much more enjoyable for us this evening as well. A massive thank you to our sponsors who help us run these events, both physical when we're allowed to do those and virtually. They've supported us continually throughout this year, enabling us to get prizes for quizzes, to send out stickers and just have this user group community, and hopefully it's all beneficial to you. So massive thank you to our sponsors for continuing to offer their support towards us. Now, I also wanted to call out something that we're running in conjunction with Microsoft, and that's a Cloud Skills Challenge. So Microsoft have sponsored some prizes for this Cloud Skills Challenge, where if you sign up and complete 5 of the specified modules by the 21st of December, you'll be entered into a prize draw. I think it's open to everybody, might just be open to UK people. I'll need to dig into the terms and conditions, but there are some good prizes around. I think the first prize is a Surface Go. Second prize is some Surface headphones, and the third prize is a swag box. So completely free to join. You will learn something by completing the 5 Microsoft Learn modules, and hopefully you can win a prize as well. So please do check out the link on screen, sign up, have a go. You could win an awesome prize as well. So thank you to Microsoft for doing that. And last but not least, today's agenda. We have 2 awesome speakers. We have Donovan talking about digital transformation. We then have Heini talking about big data, which I know nothing about, so I'm looking forward to learning something tonight. We're also hoping to have a roundtable, just chat, networking, share some thoughts. Anybody got any problems or want to chew the fat with us, then we can actually do that tonight as well. And last but not least, we have our traditional quiz. It is a bit Christmassy tonight, so there's some Christmas questions in amongst all the Azure questions, and we've got 3 awesome prizes for you tonight. I think first prize is a Logitech keyboard, second prize is a mouse mat that lights up and does all fancy things, and third prize is a much needed webcam for all of our virtual events that we're doing. So again, thank you to everybody for supporting us tonight. I think Donovan has said that he wants questions put into the chat box, and you'll get them to the end of the presentation. So please do that, make most of his time and ask him some questions. But yeah, thank you so much for supporting us, and I will hand over to Donovan to present for our first session tonight.
Cool. Thank you so much for having me. Let me know when you can see my screen and we can go ahead and get started.
Yep, I can see it, Donovan.
Perfect. So my name is Donovan Brown. I am a principal cloud advocate here at Microsoft. I lead a team. One of the teams is where Sarah works, so they do all my modern infra. I also have a lift and shift team, and I also have a DevOps team. So I span quite a few things here at Microsoft, but I made my name in the industry as a DevOps guy. So I've been doing a lot of that for a long time, and that kind of dovetails really nice into digital transformation, which I'm actually here to talk to you about today. And it's interesting because I'm talking to you virtually, and that is a sign of digital transformation. We can't meet physically anymore because of the world that we're living in today, but it's digital transformation, this digital world that we live in, that allows us to continue to connect, which is really important. And I don't think anyone would argue with the statement that's on the screen right now. The world really does run on code. People don't even realize when they're interacting with code, right? They're like, oh, I hate computers, I never use them, but then they go and they pump gas in their fuel and they pay with it with a credit card, and they don't realize that there's technology and computers behind all of those transactions that actually happen throughout your daily life. They change the way that we communicate. They impact the way that we travel. Depending on what apps you have on their phone, they might be the way that you fall in love. It's the way that we educate ourselves, the way we entertain ourselves is all about this technology. And the world that we're living in today, where we physically can't go places safely, well, not here in the United States. I know other countries are doing a lot better than we are. These digital transformation has allowed us to stay safe. I still order pizza, I still order my groceries, I still order the stuff that I need to for my daily life, but I don't have to physically go get it anymore because I can do everything on my phone because of this digital world that we live in. And what we've noticed is not only does it permeate our world in a very impactful way, that organizations and companies are realizing how important this is, right? So 91% of businesses have realized that when they start this digital transformation, when they force their people to think differently, it sparks innovation. It makes them want to try new and amazing things and use the cloud and other assets that we have available to us to go ahead and start to push the envelope and blur that line between the physical world and the digital world. Well, what I think is even more telling is that 85% of people have realized, or companies, that if they don't do this, they're going to be the next Blockbuster or the next telephone company that's been displaced by Netflix or by Skype or bookstores that have been displaced by Amazon. If they do not go and start this digital transformation, this could be really, really bad for them. And when you're talking about a digital transformation, it's not about just lifting and shifting your workloads. It's about changing the way that you deal with infrastructure. You no longer want to rack and stack and hug servers anymore, right? What you want to be able to do is use the infrastructure when you need it and then throw it away when you no longer need it. It needs to just be a commodity now, not this thing that you have to babysit and patch and restore. We need to change the way that we think about our applications. Our applications now need to allow our customers to use our products and services from anywhere. If I'm physically in the store, if I'm using my mobile phone, if I'm home on my web browser and my main computer, I should have a unified experience across all of those types of modalities of using that product or service from our customer. And another thing that they need to realize is that the data that they collect, we collect massive and massive amounts of data, and we're just collecting it sometimes just to be collecting it. But there's intelligence in that. There's insights in that data that you can use to make sure that you're giving the best experience to your users. I used to race cars for fun. I still race them every once in a while, but I ran a website called DLB Racing. And I was collecting all kinds of crazy data, like what tires do they run and what cars do they drive. And then a tire company came to me and said, we're really interested in that data that you have about what tires people are running on. We want to know what sizes that they're running. We want to know what compounds that they're running so that we can go focus our efforts towards that type of tire. I was like, holy crap, I was collecting that, but I had no idea the power in the data that I was actually collecting. And I think a lot of customers and companies are in that form where they're collecting data, but they're not really analyzing and using that data to drive a better experience for their end users, and they need to. The reason why is because the digital world is the world that we live in, and to not do this is an economic imperative. Those who are on this transformation are many times more effective than those who are not, and it shows in their profits. And what we can't do is simply sit back and keep doing things the way that we've been doing it before. Another thing I think is dangerous about ignoring the digital transformation is the more successful you've been without it, you think you don't need it. But those small companies that are out there being born in the cloud, using digital transformation as a way to innovate and outpace their competitors, are eventually going to disrupt the world like we've seen disruptions already, and we have several examples. So what I want to do right now is I want to show you a quick video that will emphasize the fact that no matter what industry you're in, no matter what size the company that you work for, a digital transformation is extremely important for you to embark upon.
No matter what industry you are in, whatever types of customers you serve, your organization is transforming. Today, more than ever, you need to rethink what is possible and become more resilient for a changing world. You need to embrace new ideas, processes, and technologies grounded in a strong sense of purpose to empower each other, our communities, and the world around us with security, continuity, and resilience being top of mind. Data drives information, information drives insights, and insights inform decisions and create methods to help you respond, recover, reimagine. New business models, new products, new markets. It's no longer just about one simple software solution. To reimagine your business, you need to create a connected, efficient, and scalable digital ecosystem. It's time to transform and think about your own future as a digital company. How? Through customized industry solutions built on an integrated cross-cloud platform that empower your people with the right technologies and products to achieve more. that seamlessly combine leading business intelligence and productivity solutions with the power of the intelligent cloud and intelligent edge, where you can build your own digital and technological capabilities with the unique support of the largest partner ecosystem. It's time to take the next steps in your digital transformation journey. Your vision, your data, your customers, your future. Today, Microsoft, empowering every person and every organization on the planet to achieve more.
One of the things I like most about that video is that it didn't focus just on the technology. It focused on the entire evolution of your organization. You have to engage your customers in ways you've never engaged them before. Like I talked about before, using your phone, using mobile, using whatever experiences that you can to engage them and keep your customers. You need to empower your employees with the data that you're already collecting so they can have like a superpower and use that intellect and that information to go drive a better experience for their customers. You have to optimize your operations and think about infrastructure in a different way. Start doing best practices like infrastructure code, which we'll talk about later, and allowing you to use the elasticity of the cloud to be able to burst out into larger footprints when you need to, but then shrink back down so you're not wasting money when you don't. And then again, transform your products. Don't think about how we used to do things. Think about how we can do things now that we have the power and the innovations that we have available to us today. We have things like serverless and Kubernetes. We have these things that just empower us to do things that we've never done before. So I challenge everyone to transform your products, rethink your infrastructure, to empower your people, to give your customers an experience that they've never had before. Now, I'm a computer person. I love geeking out. I know you do too. So what we're going to talk about today is cloud computing. But all that other stuff has to happen. You got to engage your customers. You got to harness your data. You got to rethink your infrastructure. But what I want to focus on right now is how the cloud can help you along your digital transformation and some of the benefits that you get when moving to the cloud. Benefits of the cloud are immense, and this is not a complete list, but one of them is high availability. I always laugh when I think about high availability because in this very room, I used to have a big, tall rack. It's now in my garage. And I had Dell servers in it, and DLB Racing that I was talking about earlier used to run out of this actual room. And I was a consultant, so that means I would fly all over the world. And if anything ever happened, I remember having to call my mom and say, hey, Mom, like, here's where I hid my key. I need you to go to my house. I need you to reboot this server because it's really, really slow. It's running out of memory. It was ridiculous, right? And if my mom was busy, I had to call my buddy Abel. I was like, hey, Abel, my mom's busy. I need you to go to my house and I need you to reboot the second server. Like, the database server is taking too long to do something. So I did not have high availability at all. And because I only had 2 servers in my room, I had no scalability or elasticity. I was stuck with just those 2 boxes. And if I physically wasn't here, I had to get someone to physically come to my house and do some of those machines. It was ridiculous. But when you move to the cloud, all that goes away. I have high availability because the cloud spreads across the globe. And I can make sure I have multiple versions of it running in different areas so that should one of them have a problem, the other one will keep running. I can also have geo distributions for speed. So I can actually serve the data from a machine that's closer to the people who are actually trying to get to it. If I were to have a spike, and every year I did have a spike, and it was a miserable experience because one club would run what they call a season subscription, and you could buy the whole year's worth of races up front. And I would just watch my machines crawl to a halt, and all these hate emails would start coming in of people who were getting server errors and it wouldn't work. And for like 3 or 4 hours, my poor machines were just running at the hardest they could. And it was a miserable experience for the end user. But luckily the rest of the year, I didn't need it. It's almost like my own Black Friday or Cyber Monday, right? But I wasn't prepared for it. In the cloud, you can always be prepared for it because as the spike of traffic starts to come in, you can automatically just scale out using the elasticity of the cloud to whatever amount of infrastructure that you need to sustain that. Here in the United States, we just had Black Friday and Cyber Monday. Those days are hell on retailers, especially e-commerce retailers, because we're coming and we're wanting the best deals and we're coming in droves. And if you don't have the infrastructure for it, it can be really painful, but the cloud allows you to scale out as much as you need to. Also, the geo-distribution does a couple of things for you. Disaster recovery and geo-distribution to me kind of go hand in hand. It's very rare that something's going to happen in the United States and then also happen in Europe that are going to take down 2 data centers at the exact same time. So by having my infrastructure actually geo-distributed, I can actually recover from disaster really quickly because I can have a firewall or a gateway in front that says, this is my primary, and should something bad happen, I want you to fail over to my secondary, which I know will be up because it's literally continents away from where we are running right now. Fast innovation. because you don't have to rely on your data center, your own private cloud, your own private data center to have these new features. When Kubernetes comes out, we have it. When serverless comes out, we have it. Whenever these new innovations come out, we're putting it in our public cloud, and you can rely upon that versus you having to wait for your teams or your buildings or your budget to even allow you to go provision that stuff in your own private data center. So I'm not going to go through all of these, but I just wanted to talk about the cloud brings a lot of potential and options to the table when you start to move from your own privately managed data center into a data center in the cloud. One of the other things that it does is it changes the way that you do business internally, right? So you're going to go from what we call a CapEx to an OpEx. CapEx stands for capital expenses. And this is, for example, let's talk about Black Friday and Cyber Monday again. If I'm a retailer and I intend to be open those days, and I'm definitely going to be, what I have to do with a capital expense is I have to buy enough servers to be prepared for those 2 days out of the year. But the other 363 days out of the year, I really don't need these servers because we don't drive that much traffic. The infrastructure that I have is plenty enough to handle every other day of the year, but those 2 days out of the year. And it's really expensive for me to have to go buy all these servers, and they just sit idle the majority of the year. But I'm still having to maintain them. I'm still having to patch them. I'm still having to make sure that everything is working on them, because when I do need them, I'm going to start firing up all these machines, and then I'm going to use them. What's really sad is I have to spend all that money up front for those 2 days out of the year. And then by the time it comes around next year, they're obsolete and have to be replaced and have to do this all over again. But if you were in the cloud, you would just use what you need, and then when you need more, we'll give it to you, and then you go right back down to what you were doing before. Not to mention those machines have to be maintained. They're physical machines, so you have to check the hard drives and the cabling and the memory. You got to rack them and stack them, and they depreciate. So even doing your taxes is more difficult with a capital expense because you have to depreciate these machines over the life of their existence with your company. And then you have to dispose of them. There's just so much wrong with this capital expense way of doing business. But when you move to the cloud, you have an OpEx. There's no upfront cost, which means you don't have to be an HP or a Walmart or some big company to be able to get into this new environment. Anybody can get started with the cloud because there's no upfront cost. You just pay for what you need. And as your service becomes more popular, you can use more services, and the revenue that you're generating from your service will be able to compensate for that, but you didn't have to have a huge investment upfront. Only pay for what you need, and you get to instantly depreciate or deduct the amount of money that you spent on that operating expense that you're paying month to month, or however you're doing your billing for your cloud services. So again, it makes life a lot easier when you're moving from this capital expense, this big, huge upfront cost and depreciation and physical maintenance, to a cloud-based operations expense where there is no upfront cost, no maintenance, and you only pay for what you need, and you instantly get to deduct it. So a lot of people don't talk about how it impacts your finances and your taxes when they're talking about moving to the cloud, but I think that's an important one to remember. The other thing I want to talk about are the different types of clouds that there are. There's the public cloud. Think AWS, GCP, Azure, right? These are publicly owned and operated by someone else, like everything, the infrastructure, the cooling, the air conditioning, the power, the security, everything, facilities, everything is managed by someone else, and then you're able to use their resources through the public cloud. Private cloud is not just your data center. I want to be very clear. Just because you have an on-prem data center does not mean you have a private cloud. You just might just have servers that are in your data center that you happen to use. A private cloud needs to offer services like IaaS, PaaS, and SaaS, which we'll talk about in a moment. So as a developer, just because you happen to have a room with servers in it does not make that a private cloud. Yes, it's a data center, and I might be able to get a VM inside that particular room, but unless you offer me PaaS, SaaS, and IaaS features, it's really not what I would consider a private cloud. And where a lot of companies are going to be living for a long time is this hybrid model, where they might move their databases to the cloud because they need more scale than they have physically on-prem, but they leave their web servers on-prem, or vice versa, they flip that around. But they have some of their resources on-prem, they have some of their resources in the cloud, and that hybrid world can actually exist because we have infrastructure that will allow you to have private networks that bind your public and private clouds together and give you this hybrid experience. It's great because it allows you to move slowly into the cloud. You don't have to rip and replace everything. You can just move piecemeal until you finally get yourself all the way into the cloud. Another thing I want to talk about is the services that these clouds should provide. Regardless if it's public, private, or hybrid, what you should be getting are services out of that cloud. And those services are usually called IaaS, PaaS, and SaaS. IaaS is infrastructure as a code. I'm a big car guy, so I use car analogies a lot. And if you think about IaaS, it's like buying a car, right? You buy a car, it's great. You're excited, you have a new car, but you also have to get the oil changed, you have to get it maintained, you have to buy new tires, you have to get the windshield wipers replaced. You own that car. When you have an IaaS VM, you have to patch it, you have to reboot it when it's time for a service pack, you have to make sure it's secure. Like, we give you the VM, but that's your VM. That is your car, and you're responsible for everything that secures and maintains that particular entity or that car. PaaS, which is my favorite type of cloud, that is like renting a car. And you know how we treat rental cars. You rent the coolest car you can get your hands on, you drive it like crazy, you're slamming on brakes, you're doing stuff in this car you would never do with your own car. And then when you're done, you just throw the keys back to the poor person behind the desk and say, thanks for the car. And they have to go make sure that the brakes are still good, that the tires are still good, that everything is performing the way it's supposed to perform before they give it to someone else. All the horrible stuff that is about owning a car, you don't have to deal with that. You just get to have the fun side of owning a car. So PaaS, think about app service, AKS, those services where we provide you the service, but the infrastructure is managed by us. Those are the kind of things that I'm talking about. And then on the far right is what we call SaaS. This is like calling an Uber. You don't own the car, you're not renting the car, you're just temporarily going to be using it. You bring the data, the rest is done for you. Think of things like Gmail, Azure DevOps, Office 365, where you use a web browser to access the service, and the only thing that you provide is the data, and the rest of it's all managed for you. So IaaS, PaaS, and SaaS are the type of services I would expect to find if you're in a public cloud, private cloud, or even in a hybrid cloud scenario. Another way of looking at this are the different responsibilities that you have. So as you move, from on-prem to PaaS, the level of responsibilities change drastically. When you're on-prem, you are responsible for everything. The networking, storage, servers, OS, middleware, data, application, all of it is in your responsibility. As you move to IaaS, which is in lifting and shifting your code to the cloud, running potentially the exact same version of the OS, the exact same version of your web server, the exact same version of all your packages. It's really easy and familiar. You just lift and shift here. We'll take care of the networking, the storage, the cooling, the security, and you still have to maintain the OS, the middleware though. So that means if there's a Windows patch or updates to the Linux kernel, you have to install those. You're going to have to reboot the servers. You're going to have to be able to maintain and deal with that downtime that's going to cause in your system, and potentially be prepared to deal with that. You also bring your data and your application. If you go to PaaS, again, app service, which is hands down my favorite service in Azure. I know everybody's all excited about Kubernetes. Like, nope, app service is freaking awesome. I don't care if it's a WAR file. I don't care if it's a zip file. Give me your binary and I'm going to go host it for you, let you scale it out and give you zero downtime deployment. It's freaking awesome. And I'm a big fan, and I don't worry about rebooting servers. I used to have, when I ran DLB Racing out of my house, I'd obviously have to install Windows service packs and have to reboot my servers. I had a Twitter account just for DLB Racing, and all I would ever tweet was, hey, got a Windows security patch, rebooting the server tonight at 3 a.m. I'd go wake up 2:30, get ready, install the service pack, reboot the server at 3 a.m., and then tweet out, okay, everyone, server's back up. Sorry for the inconvenience. Then I moved to PaaS. I've never tweeted that out again because all that server maintenance is done for me. Yeah, they still patch the servers, but I'm not aware of it, and my site is not aware of it. They will move my site without any friction or downtime from that server to another server. My customers are still using it. They will then patch that server, reboot that server, and then make that server available for the next time they need to move me back to patch the server that I'm currently on. But to me, it's completely invisible. I hadn't tweeted since I moved to Azure about ever having downtime again, which is fantastic. So that's some of the benefits of it. So what I want to talk about right now is your journey to the cloud. You start off in your own data center with everything maintained and owned by you. And then a lot of people want to lift and shift into IaaS. And the reason they want to do that is because VMs are familiar. You're probably running on VMs in your own data center. Very few of us are actually running our workloads on the bare metal. We're usually running inside of VMware or Hyper-V. We have some type of virtualization going on. So I'm still running inside of a VM. And if I want to lift and shift my app into the cloud, I just spin up a VM with the same OS, same dependencies, and I can literally copy my files there and it'll just run. Open up the same ports on the firewall and we're off to the races. But you still get some of the benefits of moving to the cloud. You can now scale that out because you have infinite scale in the cloud. You can create VM scale sets and do cool things like look at the memory usage or look at the CPU. And if they start to get really high, go ahead and start scaling that out for me so that I can sustain a lot of simultaneous users. But it still is IaaS. You still have to reboot the servers. You have to have a scheme and a methodology for how you're going to be able to do that with zero downtime. There's a lot more maintenance there. Depending on the app that you're writing, you might actually be able to move directly to PaaS. And we have some cool migration tools that will allow you to evaluate your current application running inside of IIS or running inside of Tomcat and say, hey, by the way, you can skip over VMs altogether and just move this directly to IIS and it'll just work, right? We're going to give you all the flexibility of the cloud, zero downtime deployments, auto scaling, and we'll just take your WAR file or your zip file or your Go.exe and we're just going to run it for you inside of PaaS. And I think PaaS is where a lot of people like that sweet spot. And I think it's a really great way for people to start if they can. Now, serverless goes to the far extreme. I have this one microservice that I need to write. I don't need to know anything about the infrastructure. I just need you to host this endpoint for me that goes and does some really cool things for me. And serverless is a great way to be able to just really focus on delivering value to your end users. And to the far right is what we're calling low code, no code. Think about Power Apps and things like that, where you don't even have to write any code at all. What you do is you simply leverage services that already exist that might be living inside of serverless, PaaS, or even IaaS, or even on-premise for that matter. And then low code allows you to leverage those services that are already provided in those APIs to build applications for areas like the marketing team or the HR team who aren't programmers, but they know what they need to get done and they know what services are available, can now start to use low code and no code to build their own applications and to utilize the power of the cloud to scale out and start to deliver value as well. So what I like to do is just kind of lay out where you might be today, which is on-prem, and where you can aspire to be, which is just being able to deliver value without writing a single line of code and everything in between. And you're probably going to be somewhere on this path, and you can pick up from wherever you are and start to move a little bit further to the right. Now, the more I've been researching digital transformation and app innovation, being a DevOps guy, I realized they kind of work together because you kind of want to start delivering code as fast as you can, utilizing a lot of these best practices that are born out of DevOps. And if you ask us at Microsoft what DevOps is this. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word is value. It is not about delivering software. It's not about delivering features. It doesn't matter how good your features are if your infrastructure is never up, because you still can't access that particular feature. It doesn't matter how reliable your infrastructure is if the features in your application aren't user-friendly or aren't being used by your end users. You got to do both of those. You have to have great features on a reliable infrastructure to actually deliver value to your end users. And what I love about focusing on value is it causes the operations team and the developer team to finally start working together, because historically they don't. Historically, they blame each other for everything. Sarah's laughing, but she knows she's blamed developers for stuff that was not their fault, right? Just because she didn't configure the firewall right, I'm the one getting in trouble for this? No way I'm getting in trouble for that. And they're like, no, the programmer did it wrong. No, the operations person did it wrong. And the reason why is because we were incentivized differently. As a developer, I'm incentivized to deliver features as fast as I possibly can. As an operations person, historically, they're incentivized by keeping the lights green. We want to keep healthy, reliable infrastructure. You know the easiest way to keep the lights on a healthy infrastructure green? Don't touch the infrastructure. If it's already working, don't change it. But you just told your developers, go change that infrastructure as much as you possibly can by adding features. So they're taught and designed to work against each other. But when you force them both to drive towards value, they naturally have to work together, because you can't deliver value with 100% uptime on software that's no good. You can't deliver value with software that's really good on infrastructure that doesn't stay up. So you need to work together to deliver value and reward them accordingly, and the teams will naturally work together. So I love this definition because it focuses on value and not on technology or software. But you need people following a process enabled by products to continuously deliver value to your end users. Okay? So one of the best practices that you can use inside of DevOps is one called infrastructure as code, which I have to tell you, when I first started doing DevOps, this was not important to me at all. I've been writing software for almost 30 years now. I started down the street. I live in Houston, Texas, and I'm pointing down the street like you can see. But down the street from here is where Compaq Computers was founded, right? And it's now HP. But I used to work down the street at Compaq Computers. And back then, the infrastructure that I worked on didn't change very often. The application did, but the infrastructure was pretty static. And yeah, that's still true for a lot of people. The infrastructure does not change very often. So infrastructure as code doesn't seem to add a lot of value until you start to move to the cloud. Because if the infrastructure doesn't change, why am I going to invest all this information or time into being able to automate it? But when you move to the cloud, that changes drastically. Infrastructure as code is the practice of taking the desired state of your infrastructure and codifying it into a file that you can then store in version control and act upon it throughout your CI/CD pipeline in an automated fashion. This opens up tons of opportunities for you. It allows you to review the changes. Because I know for a fact I've lived in a world where everything was working great. I went to sleep, I woke up, it wasn't working. Why it wasn't working is because someone went into the portal, thought, that's interesting. I don't know why that port is open. That's not a standard port. I'm going to close that port on the firewall, not realizing that there's a lot of information that's being transferred across that port internally that's now not being able to be transferred because they went and changed that particular configuration manually in the portal. So now I wake up and my app's not working. I'm freaking out. We're all pointing fingers, and it's now a needle in the haystack because I didn't know someone went and did that. But if the only way that they could close that port was to change a file in source control, we could review that change before it went out and have a conversation. Oh, okay, maybe I wasn't clear, but the reason I need that port open is X, Y, and Z. So we're not going to approve this change that would then go close that port and bring down our entire system. So being able to review the changes to the infrastructure is great. Being able to audit the changes to the infrastructure. Maybe we all agree that that's the right change to make, and then we deploy it and all hell breaks loose. We can look at what changed it. Oh, wait, we clearly don't understand the system well enough because we all agree, but that was not good. And now we can audit the changes that we've made, revert that change and get ourselves back up and running again, and then go do some investigation on why that change had the effect on our infrastructure that we thought it did. You no longer have these snowflake servers. You know the servers that I'm talking about that only one person knows how to build, that only one person in the company. And what's really weird about that is sometimes the one person who knows how that thing is built doesn't work at the company anymore. So no one touches that server. No one knows how to rebuild that server the way that it is. And it is the most important and valuable server in the world because we could not duplicate it again. When you use infrastructure as code, those go away because the definition of that, the configuration of that server is now versioned and easy for everyone to read. And we can stamp out as many of those as we possibly could want. Another thing is configuration drift. Configuration drift is when you go from one environment to the next and they're slightly different. And as a DevOps person, I hate that because the whole point of having a dev environment, a QA environment, a staging environment, and a prod environment is to test my deployment over and over and over again. With every deployment, I'm building confidence in my process. I'm getting assurance that it's going to work so that when I get to production, there's no doubt this is going to work because I've seen it work in dev, I've seen it work in QA, I've seen it work in staging. I know it's going to work in production. But if dev, QA, and staging are all slightly different, then I'm really not learning anything. Because if production is different from staging and it breaks, it's because they're different, not because the process didn't work. Infrastructure as code allows me to make sure that my dev environment looks just like my QA environment, looks just like my staging environment, looks just like my production environment, and I won't have that drift. Another thing that's really cool about drift is that needle in a haystack I just described earlier, where someone goes in and manually changes something because they have admin permissions inside of Azure to change a port. That would be a needle in the haystack unless you're using infrastructure as code, because my infrastructure as code file would say port 80 has to be open no matter what, or port 8080 has to be open no matter what. So instead of me trying to go find the needle in the haystack, I would just run my pipeline again and say, hey, pipeline, go to my infrastructure, find out what's different, and put it back the way it was supposed to. And it'll see that, oh, wow, interesting. Port 80 is not open, and you say it's supposed to be open, so let me open it again for you, and then boom, your app is automatically working again. So it just speeds up your development. It speeds up your disaster recovery. It reduces human error because you have this file that defines what your infrastructure should look like, and you're able to act upon that infrastructure in an automated fashion. Another additional benefits that come with it is I love temporary environments. I've been in a lot of organizations where we have a dev environment, we have a QA environment, we have a production environment, and they all stay around always. Why? Because it was so hard to stand up a QA environment, there's no way we're going through that pain again. It took us weeks to stand it up. So if it takes weeks to stand it up, I'm going to leave it there forever just in case you need it again or when you need it again, because to spin it up again would take so long we would lose time. But when you use infrastructure as code, spinning up a QA environment is just a matter of minutes. And I can spin it up whenever I need one. Even if I need multiple of them, it's just run the pipeline, change a few configuration variables, and I can have another one in a different region that looks exactly like it. What's really cool about that is I can now delete those environments when I'm not using them. So I can save a lot of money. I can have a dev environment spin up. I can run all my litmus tests, all my smoke tests to make sure that it's good. Once all my devs give it a thumbs up, it'll then go and start provisioning a QA environment while it's deleting the dev environment that we were just using because I don't need it right now, saving us lots of money. I spin up a QA environment, I deploy all my code in there, I run all my performance tests, all my automated UI tests, all my stress tests. If everything's good, I then say, let's go into production. Production is there. I still run my infrastructure as code against production just in case there's been any configuration changes. But what's really nice about infrastructure as code is that if there have been no configuration changes, nothing will happen. Then I will deploy my new code while I delete the QA environment what I no longer need. So it saves you tons of time. Another thing that I love about infrastructure as code, because it's funny that I didn't even believe in it when I first started DevOps, and now I'm like its biggest fan, is disaster recovery. I did a demo, and I think you might be able to find it online. If not, Abel repeated the demo that I did. And my goal was to push infrastructure as code to the furthest I could possibly push it. And I said to myself, my goal is to feel confident deleting every resource in my Azure subscription, knowing that I could re-provision it at the click of a button. And I'm at that point now. And I did this on stage at a conference once. I went up on stage and I told the story about, imagine that you had a system that was up and running and everything was working fine. And then all of a sudden you get an email saying something's gone wrong. You do the normal things. You start to do some troubleshooting. All of a sudden the site's not coming up, your mobile apps aren't working, and you go into your Azure portal and you realize that every resource in your Azure subscription has been deleted. Most of us would just quit our job, right? Like, job's over, go work somewhere else because there's no way I'm going to recover from everything being gone. And what I do on stage is I show them that I have an empty subscription, the website doesn't work, and I press a button and I explain to them what's happening in the background. The fact that I'm using infrastructure as code, that I'm spinning up a brand new Kubernetes cluster. That Kubernetes cluster is going to get a brand new IP address that I do not know about. And inside of my pipeline, I actually query that IP address, use a REST API to call out to GoDaddy, tell GoDaddy what the new IP address is, and update the DNS record. So that before I get off stage, people are able to go to that same website that was not working, hit F5 and refresh the browser, and that website is back up. The mobile app is working. Everything is working, and there is no human intervention besides me pressing a button. Disaster recovery just becomes a deployment. It's not all hands on deck. It's not everyone in a war room. It's not someone ordering pizza and Chinese food and we're there all night long trying to figure out how we're going to get our system back up and running. Nope. It's like, everybody, go back to sleep. I'm going to do another deployment. Our system will be back up in just a moment. Test validation, speed of procurement, it's just a fantastic, fantastic practice. So if you're not doing infrastructure as code, I highly encourage you to go do some research on that. And when you start thinking about digital transformation, I think this is one of those things that can be pivotal to your adoption of it. So before I go, what I want to talk about right now is what it looks like when you put all this stuff together. Now, don't look at these examples and think, oh my God, we have to get there tomorrow. No, you can get there piecemeal, bit by bit. But I want to give you some examples of what it looks like when you're able to put all this stuff together. So the first architecture we're going to look at, or the first pattern, is what we call high availability multi-region web application. This is what I talked about a moment ago. Use infrastructure as code, stamp out one version of your app inside of America, stamp out another version of your app inside of Europe. You can actually run them simultaneously, or you can have one of them simply be a hot backup for the first one. You put a load balancer or some type of front door in front of it, start using your primary. Should something bad happen, automatically dump down to your secondary. Your end users never see any downtime. You can go troubleshoot what's going on in your primary one and then have it fail back whenever you figure out what's going on. This is the power of the cloud. When all your servers are sitting in your room here, something bad happens, that's it. Right? There is no failing over to anywhere because it's in either your data center or it's in your house, wherever that single point of failure is, that's a problem. But in the cloud, you can have as many different points across the globe as you need to make sure that you can withstand any disaster that might come across. The next one is starting to use things like Kubernetes and containers. Now, I want to be very clear. You hear a lot of people excited about containers and Kubernetes. It's not the solution to everything. I don't want you to think that no matter what app I write from this day forward has to be inside of a container, has to run inside of Kubernetes. That being said, Kubernetes is pretty amazing technology, and it might be the tool that you need. But the way that I look at Kubernetes is this way that I look at VMs and Key Vault and all the other services inside of Azure. They're just tools in my toolbox. And what you need to do is evaluate the problem that you're trying to solve and then grab the best tool out of your toolbox to solve that. And if containers are the way that you need to go, Kubernetes is a fantastic way of doing this. And this is where you're taking your monolith that you might be running inside of a VM. You start to tease it apart and create little microservices that are very purpose-built features of your application that can stand alone, can scale independently, and even be deployed independently if need be. And using the power of containers and Kubernetes to allow you to scale, shrink, and deploy with whatever need that you, whatever pattern that you need to make sure that your customers are sustained. You can do DevOps best practices with CI/CD in front of it, using Azure Containers Registry to go ahead and store your images and deploy your infrastructure out into Kubernetes if you want to. Now, you can take this even a step further, where you're not only deploying into Kubernetes, you're developing inside of Kubernetes. You're thinking about containers from time zero. This is a cloud first type of way of thinking about it. I want to develop inside a container. I want to build inside a container. I want to deploy inside of a container. And what I'm trying to show you here is that the evolution of your application is starting from where you were on-prem, but this is the potential. The potential is having this highly distributed microservices architecture that can scale to infinite need. And it becomes really easy to develop because you're thinking about it from time zero. But this is not where you have to end up, right? This is not definitely where you have to start. You can get here piecemeal over time, adopting what parts of the cloud that you actually need from as you migrate across from where you are on-prem to the cloud. Now, the last thing I want to leave you with is where you can learn more about everything that I just said. This deck that I built and I just showed you was actually built out of a lot of the content that's inside of Microsoft Learn. So Microsoft Learn is a free resource where you can go and learn about all sorts of cool things. I actually learned how to write microservices and how to write Azure functions from Microsoft Learn. I was curious on how to do it. I found a module on functions. I read through that module. Next thing you know, I had a function on my desktop that I was able to develop and write. So it's a really cool resource. It's absolutely free. And you can actually do as many of these modules as you need to. So this is what I want to leave you with, is that if you're interested in learning more about cloud computing in general, because it's not all Azure specific. When you go through the fundamentals, they'll talk to you about data centers and what makes up a data center, all the infrastructure that goes into a data center, so that you can make a good decision on, do I want to stand one of these up on my own, or do I want to go ahead and rely on Azure to go do this stuff for me? So it's not a sales tool. I want to be very clear that it's not selling you Azure. What it's doing is teaching you cloud concepts, obviously many of which that we offer inside of Azure, but you get to make your own decision on where you want to go next. So that's all I wanted to come and share with you. And I want to thank everyone again for having me, and hopefully you got something out of that. So what I want to do now is just see, Sarah, were there any questions that came across that I can answer?
Yeah, there's a few questions here, Donovan. One is about the CapEx and OpEx
Sure.
challenge. So if you've got an org that aren't quite happy with that kind of challenge and changing of the mindset, how do you discuss that with them going forward, and what would you say to them?
Yeah, so it's not something you're going to be able to just rip and replace, because if you already have spent the capital expense, you still got to depreciate that stuff. You still have to live with that. What I would do is try to find a sample, or what I like to call a pilot project, and say, hey, on this project, we're going to want to try to do things a little bit differently. And they're like, oh my God, how much money are you going to need to go provision the service? And that's where you get to say none. Like, we're not going to need any money from you to go provision service. What we're going to do is we're going to use it. So that's how I would kind of broach the conversation, would be on the next greenfield application, small pilot project, or maybe even porting a project from where it is on today into the cloud, and talk to them about the benefits of CapEx versus, benefits of OpEx versus CapEx. It's really easy to do that on a new project or on a small project, and then they'll start to realize, oh wow, okay, what we need to start doing now that this was so successful is start migrating all of our old stuff off of our hardware that's in our data centers and move it into the cloud and start changing our operations. So a lot of the things that we do in the DevOps world and in the digital transformation world isn't flipping a switch. You don't go from A to B instantly. There's a lot of stuff in between that you have to start to work through that. So my recommendation would be, if you can find a small project that you're porting, or a brand new project, use that as an example of how you're going to start moving from a CapEx to an OpEx.
Cool. The other question was, what infrastructure as code tool do you use? Do you use like ARM templates, Terraform, Azure DevOps?
The answer is yes, right? The answer is yes. Like, we use all of those. That's a great question. So if you're only going to be using Azure, and you know that Azure is going to be the only cloud you're going to be using, then you can go ahead and bet on something like ARM templates, because ARM templates only work in Azure, right? So they're awesome, they're extremely powerful, they're very reliable, and they're idempotent. So that's one thing I didn't talk about that I'm glad you asked me about this. Idempotent is the concept, or the ability to run the exact same script multiple times in a row without breaking anything, which means if I were to run this script and say, hey, I want you to provision a VM for me, and I run it against an empty subscription, it will provision the VM for me. But if I run it again, I should not get an error. It should say, oh, Donovan, that VM you want, it's already there, so I'm not going to do anything. Or it might say, hey, Donovan, that VM you want, it's already there, but it's not configured correctly, so I'm going to go ahead and fix that configuration for you. But I should be able to run that script a million times in a row, and it should never mess up anything. So if the tool provides that for you, then go nuts. And ARM templates do that. Terraform does that. Azure, the CLI, believe it or not, there's a lot of commands in the CLI that are idempotent, that you can say, hey, create a resource group, and you can run it a million times, and if the resource group is there, it doesn't error out. It just says, yep, resource is already there. I'm just going to keep on running. And I like actually the Azure CLI a lot, because it's a lot more concise. ARM templates are extremely powerful, and we're creating a new language called Bicep to make them a little bit easier to write, but they're still verbose. And I just being perfectly transparent, if I can write mine in a Azure CLI script, I will do that first. The only time I start bringing out the heavy metal, which is ARM templates, is when, for whatever reason, I can't achieve my goal, or it's not an idempotent version of that particular resource inside of the Azure CLI. Then I'll move over to ARM templates. Why would I use Terraform? Because I'm not living only in Azure. right? A lot of our customers have to have the exact same infrastructure replicated in GCP, AWS, and Azure, and you need to use a tool that's then agnostic, and Terraform is agnostic. So you can actually use that and deploy the exact same infrastructure to all three clouds. So the answer is yes. Like we use them all. It all depends on the scenario that you're in, but I highly encourage you to start looking at infrastructure as code. One last thing I'll nitpick on infrastructure as code is that there's a difference between infrastructure as code and configuration as code. The industry seems to be kind of driving towards they're all the same thing. They're not. And the reason that I get a little more pedantic about that is because you can start doing configuration as code today, even if you're on-prem. Because configuration as code is saying, hey, I need that IIS server to have the .NET framework on it. I need it to be configured a certain way. Infrastructure as code is, in my opinion, is provisioning something that wasn't there and making sure that it's there. As soon as you start changing the configuration, that is configuration as code. And those are completely different practices, but are commonly done together, right? But I want to be very clear. Don't think that I can't start doing any of these cool things until I move to the cloud. If you have servers on-prem today, you could be using DSC or Chef or Puppet, those configuration as code tools, to start learning how do I configure in a automated way using code as my configuration mechanism. And then when you move to the cloud, leverage that, because now not only are you going to be able to configure that server correctly, you're even going to be able to spin it up and then go and apply your Puppet, Chef, DSC, whatever configuration as code tool of choice that you're using to then configure that after the case.
Awesome. And one last question is, what is your opinion of Bicep?
So right now, I believe Bicep is going to help with ARM templates, because if you've ever written an ARM template, that is not easy, right? It's scary stuff. The best way to write an ARM template is to go into the Azure portal, start to configure the thing that you want, and at the end, before you click create, there's a button that says show me the automation, and the ARM template's in there. And that's normally what I do. I will go configure what I need, grab that script, and then copy and paste the parts I need into the ARM template that I was already creating. I've seen some early revisions of Bicep, and it's definitely a step in the right direction. It's definitely easier to write than ARM templates. But what you get out of it is an ARM template, right? So it's still using the same mechanism. And I believe it's going to be really good because one of the reasons that I like ARM, I shouldn't say I like it. One of the benefits ARM has over Terraform is that when we release a service inside of Azure, the provider necessary to use ARM is shipped with it immediately. But then someone has to write an adapter for Terraform, or provider, I forget what it's called in Terraform, to then go utilize that. So there's a gap between when the service becomes available on Azure and you can use it in Terraform. But there is zero gap between the time you can use it in ARM or inside of a Bicep file and using it inside of Azure, right? So there's a benefit there if you're only going to be using Azure, I would stick with a more Azure specific type of technology like ARM or Bicep. If you have to go with Terraform, then so be it. But just know there's going to be a little bit of a lag between when the service becomes available and there is a way for you to utilize that inside of a third-party tool.
Awesome. I think that's all the questions, Donovan. Thank you so much for your presentation. It was really interesting, so appreciate that. And yeah, thank you so much again for doing this tonight.
If you guys have questions after this, the best way to get a hold of me is on Twitter. So I'm at Donovan Brown on Twitter. It's the #1 way to get a hold of me. It's faster than email. So if you have any questions that come to you that I didn't answer here, feel free to tweet them at me and I'll respond to you there. But thanks for having me.
All right, cheers.
Take care, bye-bye.
So next up on the agenda is Heini. Heini, are you okay to do your presentation?
Yes, I am. Thank you.
Awesome.
Yeah. So, all right. Let me just get my sharing going and then we're ready to kick off. Okay, I think you can see my screen. Is that correct?
Yes, I can see it. Yep.
Perfect. All right. So it's kind of interesting. We've been talking about digital transformation for this first part. And I think one of the biggest movements that I've seen in this kind of as one theme in digital transformation has also been working with data. And of course, we have all these nice kind of hip terms around data like big data and machine learning and AI and things like that. And we want to leverage those. But so what do we do in the scenario when we don't quite have big data? We have some data and we want to kind of use the benefits of what is done with big data. So how do we work with this in the real world? So that is what my session is based on, how to adapt big data architecture patterns for real world scenarios. And so to really speak about this, we first need to understand what is actually big data. We need to go looking, what is the definition? Because there is actually a definition for this that is used in most scenarios. And so you might have heard about the 3 Vs or the 5 Vs in regards to big data. And I'm going to just quickly go through the 5 to get you kind of oriented around what is meant when we talk about big data. And so the first V here is volume, which is probably the most obvious due to the wording of the term of big data. Volume just means a lot of data. And there's not an exact definition for this, but if you go looking somewhere, it might be said that it's more the scale of petabytes rather than terabytes, actually. So this means that you really have massive amounts of data. And at least in my experience working with most customers in Finland, most organizations do not quite have petabytes of data at this point yet. So we're already looking like, does that really apply to me? But also the second aspect is velocity. And velocity is talking about how fast are we taking in data. And that means that as we get more and more different kinds of data sources, we keep also getting data in at an accelerating speed as well. The third aspect here is variety. And that really means that we're not just looking at relational databases anymore, not just having tables and relationships, but also having things like semi-structured data and also completely non-structured data like photographs and things like that. But that is the 3 Vs. If you run across those, the volume, velocity, and variety, those 3 you will often run across. But in some cases, you will see 5. And if we have the 5, then we also have veracity. And what veracity means, I think, at least for me not being a native speaker, veracity is then what is the trustability of the data. So that means, can you rely on the data that you have? And that is actually really essential if you are going to start working with data projects. And then as the last step, we do have then the 5th, which is value. And that just means, is that data valuable to you? And of course, you would think that it would be useful to have data that has some kind of value to your business, to your organization, to your customers, for example. But really, even whatever kind of data we have, even if we have volume and velocity and we have all the 5 Vs, it's not really worth much unless we're actually going to be able to gain some kind of insights from that data. And so if we think about it, it is not quite as important whether you have all the 5 Vs there. We can still draw value and insights from our data if we just have maybe something like medium data, or maybe even that we only have kind of small kind of data. So today, what we'll be doing is walking through first an Azure reference architecture that is based on big data and what kind of components from Azure you're going to need to set that kind of environment up, where you can start drawing insights from your data. Then, as the second point, we're going to be looking at how do you adapt that architecture if you don't have all the Vs. So just looking at an example of how you would go about it. And as the last step, we're going to be looking at how do you really make it your own? Because the example I might be offering to you might not be applicable for your case. So I'll just kind of give you some general steps that you can follow to really make this reference architecture that we're going to pass through the one that works for your scenario. So I am Heini Ilmarinen. You might not know me beforehand, so I work at a company called Atea Finland, and I work as a solution architect. I have quite an extensive background on the infrastructure side of things, but also from my past life, I'm a mathematician and have thus been drawn to the data side of things. I am also a Microsoft certified trainer and run trainings at our company for kind of company-wide. And also, you will kind of see that I like to doodle. You might have already caught on to that. So we'll be kind of walking through this session through the pictures here. So let us start with the reference architecture. And I'm actually referencing something that can be found in the Microsoft Architecture Center. And there's the link. I can pop it in the chat as well in a later point. So you can go and find all the information related to it. And first of all, I'm just going to walk through the reference architecture, because if you understand why it's built this way, then it's much easier to adapt it to your scenario, because you understand what parts you need to keep and what you can let go. So let's start from scratch and walking from our data sources to how we leverage these data sources. So if we think about any kind of data project, we want to start kind of getting some insights from our data. We want to start finding out what's in our data. We first have to consider the data sources that we have. This might, of course, be any source systems. It can be many kinds of sources that we have. And of course, typically we have some kind of relational databases, because just a lot of applications run by leveraging relational databases on the background. So that is kind of one of the most obvious data sources that we might have in the mix. But more and more, we're also having some of these semi-structured data sources. And that means that we have things like JSON format, XML, things that do have structure, but you don't have those relations between the data points that you have. So more and more, there's a lot of variety to the types of data that we are using. But on top of that, there's also the possibility to use things like photographs, audio, video, things like that. Really kind of flexible data formats that we might have existing in our environment. And because we have such technological capabilities, we're actually able to pull data out of these very different kind of formats as well. It's not only limited to relational databases anymore. And then the fourth data source that we're going to be looking at is having any kind of streaming data. And of course, here, the first thing that comes to mind is things like IoT devices that are sending you data through sensors or things like that. But in some cases, streams can be just a system that sends you constantly data. For example, if you're pulling data from something like Twitter, there is a constant feed of data coming in. You're not pulling it from a database. You can connect directly to the Twitter feed with some search criteria, for example. So if we kind of look at these data sources, this is the point where we need to stop and think about what points of big data do we have? It is kind of built in this way where we have all these data sources. It kind of gives us that ability to have large volumes of data. In most cases, if you have streaming data, that also means that you have a very high velocity of data coming in as well. If we just look at the different kinds of data sources, that's kind of a huge variety. It's not just one type. It can be like hundreds of different types, depending on how many data sources you're connecting with. And I think the two last ones, the veracity, that is kind of something that you need to take care of in the beginning. If you cannot trust your data, then whatever you do with that data, you cannot rely on. And that kind of pulls the carpet from under the whole purpose of this thing. Why would you have, for example, visualizations of your data if you cannot rely on that data? So that is something we need to take care of. And as the last point, we really don't probably want to pull in data that we don't value, that we have no use for. We want to make sure that the data that we use has also value in it. And so once we have all our data sources in place, we need different kinds of steps in processing the data and getting it to a form where we can benefit from it, whether it's visualization or whether we have maybe an application that is using that data. We need to do some steps to get it in that form that we can use. So the first step in a data platform is to load and ingest the data. So we need to get the data in. And in Azure, the most used service for this is Data Factory. And with Data Factory, it's really easy to create batch processing on the data. So kind of take data in at specific intervals, whether it's every hour or at a shorter time, and then define what is done on that data when we pull it in. So we can create very easily these processes on what is done on the data that we pull from our different data sources. But the streaming data is different because it is coming continuously. We, in most cases, can't quite use Data Factory in a very good way, or it'll make the cost really kind of skyrocket, so you wouldn't want to go with it. And so for that case, we would use Event Hub. And if, of course, if you're managing IoT devices and you want to get that capability, you could also replace this with IoT Hub as well. But it's not really enough to just have something taking the data in. We want to also store the data in somewhere. And we need some kind of storage solution here as well. And when we are talking about big data analytics and doing analytics on our data and drawing insights, doing transformations, etc., we would want to bring in data lake storage. And the thing about data lake storage, it's built on Azure storage itself and on top of blob storage. But what is brought on top of blob storage is that support for those analytics workloads. And there's, for example, this kind of query accelerator that we can leverage to get those queries to run faster on the data that we have there. So it's really built for those scenarios where we need to get really fast queries on big amounts of data. So really, we can bring both our data from our data factory to our data lake storage and also bring in the streaming data from our Event Hub in there as well. But on top of that, we will most often also need some kind of relational database where we can create the kind of models for our data that support reporting, for example, for really doing those data warehouse type of scenarios. And for that one, we would use Synapse Analytics or the old Azure Data Warehouse. And actually since the whole of Synapse Analytics just got published on the 3rd of December, I think, this is now called SQL Pools. So the name has been kind of changing a lot. You can still find the Synapse Analytics, formerly known as Data Warehouse, in the portal, but it's a little confusing. If you feel like it's a lot to keep up with, you're not alone with that. So what we would do with the data within our storage account, we would take some of that we want to put into our relational database that we, for example, want to visualize and move it into that semantic model that we are running in that Synapse Analytics, the data warehouse side. But then in most cases, we also want to do some kind of processing on the data. We don't want to just move it from one place to another and not do anything to the data and just move it on as it is. But since we're bringing in data from many, many sources, we can start to combine the data. We can start to find new kinds of insights from that data that we have and kind of do new things with the data that we might not have been able to do when it was all spread out in different data sources. And so when we have the data within our data lake, then we can bring in, for example, something called Databricks. And this is a Spark-based service within Azure that we can use to connect both to our data lake and also to the Synapse Analytics SQL pools. So we can work with Databricks with the data in both of these places and do the needed transformations, do also kind of data science type of things, finding tendencies and trends and things like that on the data that we have stored. Also, if we want to take the next step, we can also connect with the machine learning and cognitive services within Azure and kind of go the next step, see what can we learn from this data and can we predict something to the future as well. Not just kind of do the regular aggregations of averages and things like that, but really can we start finding new things and predict towards the future as well. Now we've been kind of working with the bottom part and with the data that we have pulled into our data lake, but we still have this stream coming at the top as well. And we might want to do some processing on the stream as it is coming in right away. Maybe look for some outliers and kind of see if there's anything that we need to react to right away. And for that one, we would pick Stream Analytics, because with that one, we can look at the data as it passes through as well. So we're kind of have been going through the phases of ingesting the data, bringing the data in for storage, doing transformation and even machine learning, and also doing some analytics on the stream itself. So we're kind of getting closer to the phase where we want to serve this data. We need to have put the data that we have transformed somewhere So whatever our end user, whatever our consumer might be, they can then read it in the format that they need. And maybe one of the most obvious things that comes to mind in regards to data is, of course, visualization. And for example, if we want to pull in the data from our Synapse Analytics, the one that has been really prepared into a model that is optimized for those kind of queries over, for example, getting monthly sales or things like that, kind of numbers over specific amounts of times and all those KPIs, then what we would use is Power BI. And since we are talking about a reference architecture, it is of course saying Power BI Premium. It might not be what you need in your case, but of course, as it is a reference architecture, we're kind of going all out in this case. And the thing is here that with Power BI, you can of course create also dashboards based on your streaming data as well. So we get that in there. But you might also have different kinds of needs than just visualization. You might have an application that needs specific kind of data. And what is used in this reference architecture is then having the transformed data that has been prepped by Databricks written into Cosmos DB, and then that can be read from there, from our application. So then based on these serving locations that we have, then we can have all these different consumers in this picture, which in this case, we have some dashboards and we have an application in there, and then those will be showing the data from our serving locations. So this is kind of the big picture of the whole reference architecture. As I kind of mentioned when we were going along, that there has been a bit of changes to the data platform side of things on Azure. And you might have heard of a thing called Azure Synapse Analytics. And I just wanted to, I don't want to go into the details of Synapse Analytics because it's a lot, but I just want to show you how it fits into this picture. So you kind of can fit it in, even though this is still referencing the, so to speak, the old services. They haven't gone anywhere, they won't go anywhere. You're still kind of free to use them as much as you need to. But as said, there is a thing called Azure Synapse Analytics around now. And now that it has become generally available, it is not just this part that says Azure Synapse Analytics on the slide in the bottom. It's not just that one anymore, but it actually encompasses a big amount of services. And if we think about it, it kind of covers this area that is drawn out by this box. It doesn't have Databricks within it, but it has some services that you could replace Databricks with. So that's why I drew it also around that one. And it kind of made a nice box as well. I can't fit much more icons on the slide either. So if we just kind of look at what is included in Synapse, we have the part that used to be called Synapse Analytics in the portal, but this is now actually referenced to as dedicated SQL pools. Within Synapse Analytics, we also have the data factory capabilities, but again, they have a different name to make things easy, and they are called pipelines. Same thing. They are actually based on the same code base. Exactly same thing in a different package. Within Synapse Analytics, we'll still be using Data Lake as the base for data storage. And then we have the last portion here, which is Databricks. So Databricks is not included within Synapse Analytics, but there are analytics engines within Synapse Analytics that we can use to replace Databricks. You can also still run Databricks side by side with Synapse and kind of gain additional capabilities because it can still connect to your data lake and the dedicated SQL pools. So that is not going to change. But in addition to that, what we also have is serverless SQL pools. So you kind of have this SQL query engine that you can run whenever you need it, for whether it's ad hoc queries, any longer running queries, anything like that. You can really easily do your data exploration with that one. But we also have the Spark flavor in the mix because within Synapse Analytics, there is also Apache Spark pools as well in the mix. So really, the architecture still looks pretty much the same. We just have kind of Synapse Analytics covering a bigger part. And if we're exact, we can also link Power BI with Synapse Analytics. We can also link Azure Machine Learning with Synapse Analytics. And there is also the Synapse link that you can use to link directly to Cosmos DB as well. So really, it's a service that brings this entire area from the data platform architecture together. All right, I hope you're still with me, even though we kind of covered, there's a lot of Azure services dropped in there, a lot of names. It can feel kind of a lot to keep in your head, but you can always go back to the reference architecture in the architecture center. Great, thank you. We're still with you. Perfect. So now we kind of get to the interesting part, because at least in most cases when I talk to customers, if we think about the definition of big data with having all these 5 Vs, most customers don't have that situation. Just the first one of having volume, like petabytes of data, that's not the case in most cases. And just the velocity can also be challenging for most. It might be a little more slow pace. There is data coming in, but not massive amounts every moment. So let's just look at an example where we have a slightly more limited set of features that we need. So how we would go about this is, of course, we just start with the full reference architecture. And since we had this scenario that we don't have quite the volume, we don't have quite the velocity. And for example, in a lot of cases, customers might not have IoT data. Or the other option is that they do have IoT sensors, but they are in such closed systems that you can only pull the data out as batches somewhere outside of that system. And that is kind of very common, actually. And so what we would do in that case is go ahead and we don't have that streaming data set that can come out. That means then that we're not going to need Stream Analytics. No, I mean Event Hub first. But that also means that we're not going to need Stream Analytics either. That means we're not going to need the Power BI dashboard for that one either. And move on to just having a more simplified version of the entire architecture. It doesn't mean that we should really do big changes on the rest of the architecture necessarily. But also then you can kind of take a closer look at the rest of it as well and see whether it is all applicable in your scenario. Or whether you should, for example, do some small changes to the architecture and see whether you want to, for example, replace some of the services that are there. Because, for example, if you don't have massive amounts of data, the Azure Synapse Analytics, the former data warehouse side, that is made for kind of those places where you need parallel processing. So it is built so that you have multiple compute nodes and you bring your query in and it goes to all those compute nodes and they together get the result. So that's what the parallel side of it means. And so if you don't have massive amounts of data, that can be kind of overkill. You might not actually need that parallelism as much. So for example, in that case, you could go ahead and decide, well, I can get away with a regular SQL database. I can have the relational data within a SQL database and then do any additional data modeling that I need within Power BI. And also I took out the premium because it might not be your case that you need the premium. Pro might be just as efficient for you. And then maybe the second part that you want to assess is, for example, Cosmos DB. You might have already, because Cosmos DB is actually built for really those global scenarios and things like that. Of course, you might benefit from that depending on your scenario. But if, for example, you have already kind of an application in development which wants to use SQL, yes, there's a SQL API within Cosmos, but for that as well, you could, for example, use SQL database as well. So you can go ahead and assess each of these parts separately and see kind of how you could tweak each part and see whether it is fitting for your scenario. I'm just gonna take a quick look whether there's any questions here. I thought I saw something. Question, what size of data would you need to be using before you need to move from Azure SQL as your data warehouse before you would consider Azure Synapse? Thinking of cost too. That is kind of the, I think, most asked questions in regards to Synapse. So the data warehouse side, it is more expensive because from Azure SQL, you can go from very small to quite large. And I would say one part of it is the amount of data, but the other part is also your database design. So if you're going for that database modeling that is kind of star schema based, so that is really optimized for kind of querying, how do I explain this shortly? You have a fact table and dimension tables, and in the fact table you have all the numbers, and then you have things that you want to query those numbers by, like the date, the customer, etc. You have kind of these factors that you want to query your data by. So more you have this kind of star schema based model, the more you will benefit from the kind of having that parallel processing available. And of course, the more you have data, then you gain more benefit from that. Unfortunately, I don't have an exact number. With the Synapse Analytics, there's also the fact that you can start and stop it. So you don't need to have it running all the time. So you could run your massive processing on it and then move the results elsewhere and stop it, or you can also scale it up or down. The smallest size is, of course, several hundreds per month already, so you don't have kind of that miniature Synapse Analytics, the old data warehouse side available. But depending on whether you can really benefit from that parallel processing, the one thing about the Synapse Analytics is that it's not really optimized for multiple reads at the same time. So if you have really users directly querying the database, it might not be the right option, even if it has those capabilities for the processing of data that are not within Azure SQL. Is there value in storing data that doesn't appear to have value? Add it to the lake or swamp to find out if value can be discovered in it. Yes, I would say there can be. Of course, if you have the data somewhere on premises and you don't quite know what to do with it yet, you can move it to Azure Data Lake, and then if you have it in the same place as your other data, then it's much easier for you to do some exploration on that data and kind of test it out with different things and see if you find, for example, some kind of correlations. You might be able to find value in that data. So yeah, I think kind of the current view is keep it somewhere. If you are ready to start exploring whether it has value, then I would move it to Azure. If you would anyways be storing it on premises and you're not going to look at it yet, you can, if it's stored on premises, then you can move it to Azure when you're ready to start looking at it. All right. Where does Azure SQL Analysis Services fit in, or does it not nowadays? You're giving me good questions here. So Azure Analysis Services and Power BI, they are running on a lot of the same engine behind the scenes. So you're able to get a lot of the same capabilities within Analysis Services as you are able to get on the modeling side of Power BI. So the thing, of course, there is that you can't really scale Power BI in the same sense. If you are using Azure Analysis Services, that is something you can scale according to what kind of need you have and what kind of load you need are running at any moment. And of course, you can scale it up and down. So, and also if you have that requirement of having multiple users read that data model that you have, then because the Synapse Analytics database doesn't really support that, then you might need to, for example, have analysis services either on front of it or instead of it, etc. So there are a lot of overlap, for example, between the Synapse Analytics and Azure Analysis Services, and also Azure Analysis Services and Power BI as well. So it is definitely a complex topic. You can combine all of them or just use one or the other as well. So I think that's what I can give you in this time so I can get to the last part of my session. All right, great. I think I got that somewhat a satisfactory answer. So the last portion of this that we want to look at is how do you make this your own? Because I just gave you one example and that might not be something that is relevant to your use case. So I really want you to give you kind of a method of how you can start with a reference architecture, go step by step, pick and choose the parts that you need or you don't need, and then have your own finished architecture at the end. So how we go about it is that first you, instead of looking at the services within the reference architecture, instead you want to first pick your functionalities. So really focus on the functionalities that you need and not the services itself. So for example, if you don't need streaming data, as in our previous example, we take out the entire branch and all the services relating to processing the streaming data. But for example, if you don't need the capability to show the data in your application, the only capability that you need is to do the visualizations. Then that means that in this case, we would then take out these services. And if you are not, for example, sure whether your data is yet trustworthy, I wouldn't go to machine learning at that point yet. So you might want to take something out for now and kind of keep it in your mind. I can combine this here later, but take it out for now and make sure your kind of basics are covered. Your data has good quality. You are not having kind of dirty data coming onto your platform. You're able to first visualize it and see that your data is what you expect it to be. And from there, you can then kind of also return some of the services back as you keep evolving with this data platform architecture that you have in place. As the next step, you want to go in and scale or replace services. You can also bring in additional services if that is needed. So for example, in the scenario that we were walking through previously, we were replacing the Synapse Analytics with a SQL and replacing the Cosmos DB with a SQL as well. So for example, in this case, we could do the same things that we did in the previous one, but also if you're needing some kind of additional capabilities as well, you could bring in other Azure services into the mix. So for example, I got a chance to work with a company who had a really strong API strategy, and they wanted to then be able to publish the data that they have brought into their data platform as APIs to be called from the outside world. So in that case, they could bring in API management and any associated services that they need for that API management to be able to fetch the data directly from the data lake or from the Synapse Analytics or wherever it might be. But we can also not only take parts out of this architecture, but also bring in any additional parts that we might need. The most important part, I think, which is to keep in mind, is that really implement like you do have big data, even if you don't. That means that because in the scenario where we do have many of these services in place, you will have to go into each of them and do more detailed planning. So for example, for our data lake, so that it doesn't turn into a data swamp, you need to have some kind of structure for your data. You can't just dump all your files into your data lake. So when you're doing the design of each of the pieces, really keep in mind this thought that even if you don't have big data now, you're going to have bigger data in the future. So you really want to do the planning according to that. And so, for example, for your data lake, you want to make sure you have your raw area, You want to make sure you have your enriched area, and you want to make sure you have your curated area where your data is after all those transformation steps that you have, for example, been making with Databricks. So really, in each step where you're doing the more close designing, really think, I already have big data, because then you're going to be making the decisions that are really scalable. So really, what we've been kind of doing in this session, while we've been going through the reference architecture, we've been looking at an example of when you don't have all the V's, you're missing two of them, the volume and the velocity. I think that is probably the most common scenario, which you might be missing. And also then looking at how can you walk through it to really make it your own. And what I would like you to really take away from this, in addition to the whole reference architecture and knowing you can tweak it to your scenario, is to remember that you really do have the amount of data that you need for creating your data platform solution. It doesn't really mean whether it's little, it doesn't mean if it's big. I've seen scenarios where just by using data from Azure AD, they have gotten like tens of thousands of cost savings in a year because of licensing. So really, it doesn't look at the amount of data, it looks at how can you draw insights from the data that you have today and plan according that to the view that that amount of data will grow to the future. And at this point, I would be ready for some questions if there's any more.
Thank you for that, Heini. That was
welcome.
really good. Like I said at the top of the night, I don't know much about big data, so I now know a bit more.
Yeah.
So thank you for that. Is there any questions at all for Heini?
Yeah, I can see some typing going on. But is it just thank yous? Perfect.
Thank you.
Perfect. Then if any questions come to mind, also you can find me on Twitter. My name might not be as easy to spell as Donovan's, but you can pick it from the slide.
No worries.
Thank you so much for having me. It was really a pleasure to be part of this.
Thank you so much.
And there is a question.
Yep.
I have huge CSV files. Should I upload them into my data lake as Parquet files? You're going into the nitty-gritty here. I would say that for a lot of the analytics tools, they are really, you'll get more optimized queries on your data if it's Parquets. So one of the models would be that you bring in your data into your raw area as just CSVs, and then you transform them into Parquets. And that way you would be able to query those more performantly. And also on the other view, they of course take less space as well. So I would say yes, that might be a good idea to really have the performance and the storage more efficiently used. Yeah.
Cool.
All right. Great. Thank you.
Awesome. Thank you so much. What we're now at, people, in terms of the agenda is the networking kind of community chat piece. What I'm going to suggest is if everybody wants to take a kind of bio break and come back in 5 minutes or at on the hour at 8 p.m. or depending on what time zone you are, but back in the hour, and we can have the community chat. We can have some fun banter, as we say here in Scotland, and then we can run the quiz. So if everybody wants to go and grab a drink, some snacks, bio break, please do, and we'll be back in a few minutes. So thank you.
I can share my trick about the icons. That's the question I always get.
Oh yes, please do.
I have a Wacom drawing board.
Nice.
So I also happen to use it as my second screen today, and I have a pen that goes with it, and I do draw all the slides myself. I might use some of the real icons as a base sometimes because some of them are kind of tricky to draw.
Yeah.
But I just draw them, and then actually within PowerPoint, so I draw them directly on PowerPoint. And once you have these ink shapes, there is, for those ones, you will find a replay animation for those directly in PowerPoint. So you don't really actually have to do anything special. PowerPoint takes care of the whole animation part for you. But the one thing is PowerPoint gets a little slow on them because I think it's kind of more data for it than it's used to. So I've managed to crash PowerPoint a few times with these ones, but I find them fun.
Oh no, it was cool. It's nice to see a different take on slides, because often you see the same slides being used or the same type of presentation. So yeah, I definitely love that. But awesome.
Great.
I'm gonna nip to get another drink. I'll be back in a minute, people.
Oh, that's good.
So much, everybody, for again spending the evening with us. Appreciate you giving up your time. Again, thank you for supporting our user group. We do really appreciate it. If you've got any suggestions for speakers, anything you'd like us to do next year, if we're going virtual, how we can change up these meetups, make them more interactive. You want to do more fun things, change up the format of them, please do reach out to Gregor or I. I'm sure you can reach out to us on Twitter or wherever. But yeah, thank you again, everybody, for your support. And thank you, Gregor, as well, for helping me with all the background stuff and getting everything sorted, and to our sponsors again for supporting us. But yeah, thank you, everybody. Have a good one.
Thanks, everyone. Have a good one.
Thanks, Sarah. Yep.
Cheers,
guys. Cheers, Gregor. Yep.
Bye, everyone.
Merry Christmas, everyone.
Yeah, Merry Christmas. Bye-bye.
Cheers. Bye.
Cheers.